Hi, my name is Tony Lafferty and I manage sales in the Western region for OneSpatial. I'm based out of Auburn, California, which is about 35 miles up the hill, so to speak, from Sacramento. Today I'm joined by Luke Winters, one of our talented solution engineers, and Luke is based back at our U.S. headquarters office in Vienna, Virginia. We'd like to thank everyone first for joining us today to talk about challenges you may have with geospatial information. We'd also like to thank the Northwest GIS Users Group for organizing this event and pulling it together virtually. I trust that next year we can connect live and in person, but for now I'm pleased to meet you all in a virtual manner today. We'd like to focus our presentation on some of the work that we've been doing with a variety of organizations across different industry segments at the federal, state, and local government levels, as well as the private sector. We're helping them navigate how they handle the changes to the data coming in and dealing with the constant requirements on that data and improve those management processes. So, for those who aren't familiar with us, OneSpatial Inc. is a U.S. company that's a wholly owned subsidiary of the OneSpatial Group out of Cambridge in the U.K. The organization began its life over 50 years ago out of Cambridge Labs at Cambridge University. Cambridge still serves today as the organization's worldwide headquarters. And as I described, our U.S. headquarters is located back in Vienna, Virginia, but we have satellite offices in California, Colorado, Texas, Georgia, and Pennsylvania. And additionally, there are OneSpatial offices around the world, all providing local support and technology implementation for our global customer list. And we have significant experience across a number of different industries, including government, transportation, infrastructure, utilities, which includes the gas, water, and electric distribution, facilities management, and natural resources. And one of the keys to our success is a solid technology partnering approach. The OneSpatial team on a global level has significant experience in ancillary technologies, which are key to our joint success. Several of those key partners are listed here. And at our core, OneSpatial focuses on data management solutions to improve data quality of large complex systems. We use validation, integration, automation, and our rules-based approach to build strong data infrastructures, leading to better outcomes and making your data smarter. So while OneSpatial has over 50 years of experience developing data management solutions, OneSpatial Inc. and our work we've done in the U.S. started only about 7 years ago with the U.S. Census Bureau. Since then, we've expanded to nearly 50 clients, predominantly in that government, transportation, utility, and facility management space. And also here you can see some of the many other customers that we've had come on since Census. Some of these implementations with these customers support them with our rules-based approach to conflate, validate, and integrate their data. It may focus on their addresses, Next-Gen 911 implementation requirements, transportation data, utilities, as well as spatial data infrastructure projects. So just a few of the organizations we've been working with include states like Nebraska, where we're working with the state on automating their processes for taking data from CAMA, or their computer automated mass appraisal system, and validating the incoming information and integrating it within their GIS. We're also working with a number of GIS departments on building automated validation workflows. And at the state of Michigan and Arizona DOT, we're working with them on their spatial data infrastructures. We're building those automated workflows to ingest new data coming in, validate this information, and performing change detection to identify the deltas and integrating these changes into the source data sets to maintain proper metadata. Last, we'd like to talk a little bit about some of the things we've been doing on facility management applications. Organizations like Google's Real Estate Worldwide Services Group are leveraging OneSpatial's tools and services to implement validation on their CAD drawings to assist in easy ingestion into their asset management system, which is IBM TriRiga. We've also began to implement validation workflows to validate the TriRiga database directly. As I've described through these clients, we're working with them to implement automated tools which perform quality assurance, quality control, change detection, and integration on both spatial and non-spatial data sets. This results in reduced analyst time to spend time manually checking data, and allows those analysts to do their job, to create new products and support the mission of their organization. So to illustrate this, I'd like to review that work we did with our first customer in the U.S., the U.S. Census Bureau, and the Math Tiger Conflation Project. So Census was receiving data from over 3,200 providers. Each of those data submissions can be in a different format based on a different standard and utilizing different schemas. So we began working with Census to create an end-to-end solution to bring that data into the system, run it through our One Integrate engine to validate the data, map the schema into the required Census schema, and run change detection on that data. So there were two actions for changes that we find in that information coming in. For changes that fall within census threshold, we automatically update and integrate that data into the database. For any that were determined to be outside those thresholds, we create what we call proposals for manual view by an analyst. And any of those proposals that are accepted by the analyst will then go back into the automated process, while others will be handled manually. From there, the data sets are uploaded and the project rolls on. This at one point was a very manual process, and reviewing the data also introduced a fair amount of subjectivity to the corrections being made. And so today we're proud to say that this process is over 90% automated since leveraging the One Integrate solution, and we're working with Census to get this into even higher 90% range. So with that, I want to hand it over to Luke, who will be demonstrating our One Spatial products and our work with local governments, a state DOT, the natural resources community, and we'll close with discussion on facilities management. Luke, take it away.
Thanks, Tony. Like Tony mentioned, we at One Spatial have had a variety of customers with different business requirements. All of our customers benefit from improving their data in three ways, which creates what we call the spatial advantage. The first is data validation. Our flagship product, One Integrate, is a rules engine which allows you to define data quality standards which your organization requires to ensure proper analytics and data reliability. The rules-based engine can automate the quality assurance and quality control of spatial and non-spatial data. Proper data validation reduces time spent and the level of subjectivity that occurs when doing a manual QA/QC process. The next is data integration. One Integrate can take in data sets across your organization from a variety of sources. This enables rules to be written against multiple systems. Take, for example, if you have CAD drawings, an Esri file database, and a flat file CSV, which are supposed to be together. One Integrate can connect to all three and read the three datasets into the same engine and perform validation checks to make sure that all three systems are in sync, minimizing data inconsistencies across the enterprise and allowing for greater data reuse. Lastly, once you have identified data quality issues, One Integrate can take in the non-conforming features and use actions to auto-correct the data. So depending on your needs, instead of directly editing your data, these changes can also be generated as a set of proposals which you can review to have complete control of the changes that are made to your data. So now that we've talked a bit about the rules-based approach of using One Integrate, I'd like to talk about one of our other products, One Data Gateway. One Data Gateway is a submission portal which runs on top of One Integrate. It has a user-friendly interface and allows for collection of data from multiple sources, giving submitters instant feedback regarding the quality of their data so that they can improve it over time. This means that if you have a large number of data sources, you only need to set up your business rules once using One Integrate, and then you can have your data suppliers submit their data through One Data Gateway as many times as you need. This allows the receivers of the data to only take in clean data, and they can see feedback from each data submission. So let's look at a real-world example of these two in use, one data gateway and one integrate, with some work that we've done with LA County for their addressing checks. Of course, LA County has a huge population. In fact, if it were a state, it would be the 8th largest. So of course they have big data problems, including large addressing data. So before we get into the exact workflow of how this is done, let's take a look at the data that we're dealing with. Here we have data from the West Hollywood jurisdiction in LA County that we'll be using for this example. Let's zoom in here to get a better look at the data. And we can see that we have street center lines, parcels, buildings, and address points. We're going to get into more detail about the exact rules we've set up in one integrate, but some of the simple business rules include having no duplicate features, having no overlap between features, having address points inside buildings, and having address points with the correct attribution based on the parcel and building that they're within. So as you can see right away, we do have some issues with streets overlapping other features and address points which are outside of buildings, and that's just for the geometry. Each of these features has attribution that should be linked to one another. For example, let's select one of these address points. If we select an address point, we should see that it has quite a few attributes here, including house number and street name. These should match up against the parcel that the point is within. In this case, we see that in both the parcel and the address point data, it's 815 Palm Ave, so this one does match. This is what we'll be checking automatically in the workflow. Now that we've seen this data, let's check on how this is done in One Data Gateway. So here we are in One Data Gateway. And first I'd like to talk about why LA County wants to use One Data Gateway in the first place. Why not just have municipalities drop their geodatabases into an FTP site or email them, and then the county could deal with the business rules that they want to enforce? Well, there's a couple of reasons for this. First, like mentioned before, One Data Gateway can aid in the cleanup of the data by showing exactly where non-conforming features are. But even more than that, LA County wants to empower local municipalities to maintain their data and improve it over time, and they only need to ingest the data which conforms to their business rules. To that end, we can see that I have a few assignments, one for validation for each of the 3 jurisdictions, Lancaster, Palmdale, and West Hollywood. If this application was actively deployed, each municipality would individually be assigned a submission. So for now, let's say I'm an official in West Hollywood and I want to submit my data. So I'll go ahead and start a submission here. And here I'm given a simple web portal to submit my data. We can see that it's expecting a jurisdiction input as a file geodatabase. So I have a zipped file geodatabase here that I'm just going to drag and drop in and press continue. And once this uploads, we'll see that it is going to automatically map our attributes. But we can go ahead and check and reconfigure these if we need to. Why is this important? Well, if you have each data supplier with slightly different data schemas, maybe a difference in attribute name, you could change those here and select the correct attribute that you want it mapped to. And then you can manage your schema and save the mapping, so you only have to do this once for each supplier, and every time they want to submit a new revised data set, it will automatically be saved for them. Since we already have this automatically set, we're just going to continue with our submission. So the first thing that's happening here, we have our set of rules and actions that we've configured. The first one of which is going to be reading in our submitted data. So we can open this up and see all of our different features that it's brought in, our address points, buildings, PSAP, parcel, and street center lines. And we can see that we've brought in about 8,000 features. Our first rule set here are going to be our essential geometry checks. This is a rule set that we include for each of our customers. And what we're doing here is we're looking for common errors in geometric data, such as kickbacks, duplicate features, spikes, etc. So once this completes running through all of the features, we're going to be able to see our exact conformance levels for each rule. Let's open this up, and we can see that we do have some issues with duplicate features, but other than that, it seems like our features have good conformance levels for the essential geometry checks. Next, we're looking at the road data with geometry and connectivity checks for the center lines themselves. And we're making sure that there are no undershoots or overshoots. We're making sure that they intersect at the ends of the roads. And we're also doing an attribute check to make sure that zip codes are valid. Our next two sets here are going to be addressing checks. And we're including attribution checks, making sure that the attributes match up with the road data, and the left and right sides of the roads are correctly even or odd. And lastly, we're going to be exporting our results in the form of markups. Once we're done here, we can press continue and view our results. And we can see how well our data conforms to our business rules, either in this web interface here, or we can also download a PDF report. Let's go ahead and download that and open it up. And we can see that we have all of our different features and the conformance levels for each of our rules shown here in this report. It's great to know what our conformance levels are, but how do we make those actionable? Let's go back to One Data Gateway here, and we can download our output data. And this is going to come in just as that same Esri file geodatabase zipped up. And here we're going to have all of our markup classes. So let's go ahead and look at these in ArcGIS Pro. So back in ArcGIS Pro, I've pulled in the data that we just exported from One Data Gateway. And let's take a look at the markups which show the non-conforming features. So I'll go ahead and turn on that class. And we can see that we have a lot of markups. So let's zoom into one to check out them individually. Our first nonconformance is a spike, which was caught by our essential geometry checks. This type of error is common and typically happens with just an extra mouse click when creating or editing a feature. As anyone who's edited thousands of features like this before can tell you, this is pretty much inevitable and really hard to catch afterwards, especially when you have miles of linear data to pan around. As you can see, the markup doesn't just tell us that this issue is somewhere along this feature, but it points us to exactly where the issue is, so it can drive the user to the problem to fix their data. Let's go to another essential geometry check in the form of a duplicate feature. If I select this markup and the roads beneath it, we can see that we do have the check for duplicate features, and we have two street center lines which share the same geometry. This sort of error is another common one where you might have copied out a feature to help in creating a similar road, but forgot to move it after editing the attributes. Our next nonconformance is an attribute one, where we're checking zip codes. So let's select this again. And here we can see that it's failing the road zip codes are valid check. Let's look at the attributes here. And we can see that our right zip code is null. It's important to note that with One Integrate, we write our business rules in a positive manner. So we're saying that all zip codes must be in a certain format, in this case 5 digits. So we're not just searching for nulls, but we're actively making sure that the attributes are in the correct format. Let's look at one more nonconformance, which is going to be an address point that falls outside of a building. This has been flagged by our rules as a nonconformance since there's no building where the address point is. How is all of this working, though? How do we configure these business rules to meet each individual organization's need? Well, like I mentioned earlier, One Data Gateway runs on top of One Integrate, which is where all of this is configured. So let's take a look at that now. This is One Integrate. It's a server-based application, and it runs in a standard web browser. Right now, we're looking at a session, and this is a list of rules and actions which check how well the data conforms to your business rules, and this is exactly what was running behind the scenes in that One Data Gateway submission that we were just looking at. Let's go ahead and take a look at one of these rules and see how they're configured. So it's a pretty simple rule. If we check our rule condition here, we can see what we're doing is we're making sure that the full name of the street segment does not equal null. If you have a different need, for example, if you want to specify that the road name is a specific value, let's say Maple Ave, we can use the drop-down menus here to change this rule. So I'm just going to change this not equals to an equals, and null to a static string, and rename it MapleF. We can also have this be dynamic or based on some other attribute if we wanted. So even with a simple attribution check, the customization of these rules is quite robust. Let's go back to our session and look at the other tasks that are being done. This first task here is we're reading in the submitted data into the jurisdiction output. And this is opening what we call a data store in OneIntegrate. So let's take a look at the details of this. So here in the input details, we can see that we're uploading a file geodatabase. And if we go ahead and click on this dropdown, we see that we have a lot of different file types that we can use, both spatial and non-spatial data. In the input mapping here, we can see that we're bringing in 5 classes. And if we needed to change any of these, for example, if we brought in address points, but we had rules that were already written against something called address, we could edit these here so that way we can make rules more reusable. So this session that we are looking at here is the one that we just ran in OneDataGateway, and this is running the validations and making markups. But what if we wanted to take that one step further and we wanted to correct the data automatically? Well, we have that here. In this session, we're not necessarily validating the data against our business rules, but instead we're cleaning the data automatically by handling the geometric nonconformances, by cleaning up the points that are outside of buildings, and then we're rechecking those validation rules afterwards. So we also have this set up as a OneDataGateway submission, so let's go ahead and run through that now. In OneDataGateway here, I have my other assignment, which is to fix up the LA address data for West Hollywood. So just like before, I'm going to start a submission and upload that same original file geodatabase. And just like before, we're going to be uploading the data, and then it's going to run through all those tasks that we had configured in OneIntegrate. Once I continue here, and in this we're going to be uploading and reading the data just like before, and then we're going to be running through some fix-ups instead of markups. So we're going to be taking the results of the validation checks, so whichever spots do not align to our business rules, and then we're going to be using those and some actions in OneIntegrate to fix the data and clean it. And we can see we have much higher conformance when we're rerunning our validation rules compared to the first time we did. So once we continue here, we're just going to download this one more time as a file geodatabase. We can again look at whatever application we want to. So we're going to take a look at it in ArcGIS Pro again. Here we're still looking at that same issue that we had where an address point is outside of the building. We've gone ahead and automated the cleanup of the process at this point. We wrote an action to propose a new location. So let's turn on our proposals. And we can see that we've accepted this proposal. So we have this green line here showing that our point is going to move into the center of the building. Since this is an accepted proposal, we've gone ahead and cleaned our data and moved the new point to the center of the building. This automated cleanup can save time and provide more confidence in the data, especially for this type of situation where we have multiple jurisdictions all submitting data to one governing body. Doing these cleanups for both geometry and attributes can provide a lot of value in the organizations, especially when, like in this case, we have data sets that are managed by different people. So in this example, we have addresses points which are managed by a 911 coordinator, and the parcels are from the Department of Revenue. So you're bound to find inconsistencies which can be fixed and given back to the original data stewards, improving both organizations. On the topic of helping your data stewards improve their data over time, one last function of OneDataGateway I'd like to go over is how we can catalog our results and track the data over time. So as the administrator of the project, or the organization to which the data is being submitted, you can access this dashboard. LA County can use this dashboard to see insights into the data that they're receiving, as well as insights into their data suppliers. Which specific business rules are being missed the most, which can be seen here. Which suppliers are actually using the tool and how often are they using the tool. And finally, is the data improving over time? All that's visible here, which can help improve the county's data management process, and this also helps data suppliers improve their data over time, increasing its value and usefulness to their organization. So now that we've seen this, I'd like to go over just a couple more examples of workflows that our clients have done using One Integrate and One Data Gateway. So now I'd like to talk about some of the work that One Spatial has enabled with tax parcel integration. Organizations tend to have siloed systems for managing data, so in many cases you have a GIS organization that's responsible for creating a geospatial data set to be used for analysis and dissemination, but non-spatial data is being maintained by a different organization. So in the case of tax parcels, the GIS department might have a parcel data set that they might maintain for dissemination to the public. However, all of the rich attribution data that's in that system is maintained within a CAMA, or Computer Assisted Mass Appraisal System, and it's done by a different department. Syncing these data sets is an important process to get right. And when you do sync them, it's important to answer a few questions. Are we sure that all the data is being updated? Are there records in the CAMA system which are not represented in the GIS? Or even worse, are there parcels in the GIS that are not present in the CAMA, and therefore we might not be collecting revenue on those locations? So these are the sort of issues that we found within Cuyahoga County, Ohio. We had one tabular CAMA dataset, which is managed by the assessor's office, and the partial shapefile managed by the GIS department. So to maintain contiguity between the datasets, they implemented One Data Gateway and One Integrate to validate those together and to automate markups for nonconformances and automate fix-ups of the attributes. One Spatial in the UK did a similar exercise for Northumbrian Water, and they found that there were hundreds of water clients that they were not billing. So this can have real impacts on an organization. So now let's talk about an interesting use case from the USGS and the National Hydrography Dataset, or NHD. When the USGS was updating the NHD, they had much higher resolution LiDAR-derived flowline data, but these data did not have the attributes required to make them useful. So using One Integrate, the USGS conflated the new geometry back to the legacy to copy the attribution to the new data. This was done by selecting a tolerance for how close the flow lines have to be to each other, as well as how similar the bearings have to be. After One Integrate found a match within these tolerances, it copied over the attributes to the new LiDAR-derived data. Then, for any cases which fell just outside of USGS's tolerances, One Integrate created proposals for manual review in order to not copy over the incorrect attributes. One of our current clients is Caltrans, where we're working with both the data governance and transportation asset management teams on helping assess the data quality of their systems, along with recommending how to solve some of their challenges. For the Transportation Asset Management Group, they're in the process of implementing a Transportation Asset Management Planning System, or TAMS, to help identify and group asset management projects together, which will require work within the same general timescale and location. When you have $17.4 billion in repairing and preserving your assets, small increases in efficiency can have a huge impact on the bottom line. So to be able to implement this type of system, data from the source of each asset type, like bridges, pavements, culverts, and traffic, has to be brought together into a single linear referencing system in order to rack and stack the projects. These source systems are not changing, however. They have been implemented in using specific technology and workflows to manage each individual asset type. So the TAMS has to be integrated with all of these other systems. Integration projects like these can be extremely challenging, especially when dealing with poor quality data. In fact, there was a paper that stated 88% of all integration projects will either fail or run significantly over budget due to poor data quality. Caltrans wanted to get ahead of this and reduce project risk by assessing the data quality. So with that in mind, before issuing the RFP for the TAMS implementation project, Caltrans wanted to build out an information architecture and data quality management plan as an addendum to the RFP. This will let all bidders understand any risks and issues that could arise when performing integration work. In fact, they actually ask all the bidders to address how exactly they'll handle some of the issues outlined in these documents. Caltrans contracted with One Spatial and Gartner to build the information architecture for each asset system, for each of the components which are required for the TAMs, and determine how they interrelate. Then they build out the data quality management plan to identify any data quality issues, including gaps or missing data, improper data, and cross-system validation checks. One Spatial's role in the project was to facilitate workshops with the subject matter experts to identify what business rules and data needs that were necessary to conform to have a smooth transition into the TAMs. The business rules gathered through these workshops were then configured into One Spatial's One Integrate, and each asset system was validated. These results of the data quality management, along with the issues, risks, and mitigation recommendations, were put into the data management plan. The last use case I'd like to talk about today is how our customers, including Google, have leveraged One Integrate and One Data Gateway for use in facility and asset management systems. At Google, we're working with the REWS, or Real Estate Worldwide Services Group, within their Quality Assurance Department. The REWS group collects CAD drawings for each floor and every building that they own throughout the world. This includes over 2,000 floors of space, and these drawings get migrated into their asset management system, Tririga. What we found when working with clients, including Google, on CAD and asset supply chains is this workflow. The goal is to make the CAD drawings and then ingest those drawings into Tririga to render the drawings inside an asset management application to aid in resource planning. Unfortunately, in order to get these data into these types of systems, the system expects the data to be in a specific format where certain objects exist in the right levels. When the data is not correct, the system will either fail to ingest the data, the system will upload only part of the data, or the data will not render properly. Therefore, the data needs to go through quality control and standardization before it goes into the asset system. And this process requires substantial manual review, which is typically done by a team of contractors and often occurs weeks after the initial drawings are completed by the engineering team. Often by the time the errors are found, the engineers may have moved on to other projects and have to reorient themselves with the data before completing the fix. Additionally, with the process, if the reviewers miss errors, end users may find these issues themselves in the data, leading to a lack of trust in the data. At One Spatial, we help facility management organizations on their data supply chain by putting a series of checkpoints on the data as it moves across the organization. These checkpoints involve One Spatial working with subject matter experts in the organization to determine the business rules and configuring them within One Integrate. And then these checkpoints not only improve the accuracy and consistency of the data, but allow the data quality plan to turn from a singular event for each drawing into an ongoing maintenance process. So with that, I'm going to want to send it back to Tony to finish up, and we'll have a few minutes for questions if you want to hear more about any of these workflows after the talk.
Luke and I and the entire One Spatial team would want to thank you for participating in today's presentation and your overall support for the Northwest GIS Conference. Please reach out to us directly if you have any questions or you'd like to schedule a call to discuss some of the items we covered today in greater detail. We look forward to working with you all. One Spatial, ensuring the compliance of your data for use across your enterprise.